What's going on, everybody? Got another video here for you. This time we're going to find the domain of this function here. So it's a rational function, but you notice it has a trig function in there. So we've got f of x equals 1 over 1 minus 2 cosine x. So what is the domain? Well, we know when we have a fraction, we cannot have 0 in the denominator. So we want to know when is the denominator equal to 0. So let's take the 1 minus 2 cosine x and set it equal to 0. So we get 1 equals 2 cosine x. So we're just adding 2 cosine x to both sides. So we're just moving this to the other side. And so this is going to give me cosine x is equal to 1/2. Now, we need to find all the values where this denominator is 0. In other words, when is cosine x equal to 1/2? All the values. All right. So we've got cosine equals a positive number. So that means that our solution is going to be in the first quadrant and the fourth quadrant, because that's where cosine's positive. It's positive in the first quadrant and it's positive in the fourth quadrant. And I don't know if I said fourth quadrant earlier. If I didn't, I meant fourth quadrant. All right. Now, let's look at this. Let's look at our first quadrant angle. So cosine of what is 1/2? Well, the cosine of 60 degrees, right? That's in the first quadrant. So the cosine is 1/2 when x is pi over 3. Remember, pi over 3 radians is equal to 60 degrees. All right, so we know it's pi over 3. Now, what about our fourth quadrant angle? Well, pi over 3 is our reference angle. Okay, remember your reference angle is in the first quadrant. So that's your reference angle. And we can use that reference angle to get this x value here. Okay, remember your reference angle is measured off the x-axis. All right, so now we know that this angle x here is 2 pi, if we go all the way around, 2 pi minus pi over 3. So x is equal to 2 pi minus pi over 3. So we get x is equal to 5 pi over 3. So these are our two values that give us the solution for cosine x equal 1/2 from 0 to 2 pi. We just went around one time and found all the solutions. Well, now we've got x is equal to pi over 3. All right, now think about this. So let's suppose we're here at about right there. That's our pi over 3. Now remember the fact of coterminal angles. So if we're here at pi over 3, if we add 2 pi, that gets us all the way back around, and it'll land here. And then if we add 2 pi again, add 2 pi again, add 2 pi again, all of those are coterminal angles, and that would give us a result of cosine x equals 1/2. So look, just add 2 pi to pi over 3. So pi over 3 plus 2 pi, that's going to be 7 pi over 3. So 7 pi over 3 would be a solution. And then if we add 2 pi to that again, that's going to give us what? 13 pi over 3. Okay, and that would also be a solution. And then we could add 2 pi again, 2 pi again, and we can also subtract 2 pi. Just keep subtracting 2 pi. But you're not going to write all those down. And so we would put plus, all right, so we're going to add 2 pi an infinite number of times, so we say 2n pi. All right, and then that would be the same reasoning for the 5 pi over 3. X equal 5 pi over 3 plus 2n pi, where n is any. So how many times are we going to add 2 pi? Well, we can add it once, twice, 3 times, 4 times, 5 times, 6 times, or we can subtract it 1 time, 2 times, 3 times, and so on. So where n is any integer. All right. So the domain would be all real numbers except where x equals this and x equals this. And so that would be your domain, all real numbers except for these values here. So, you know, it's really nothing different from finding the domain of a rational function. We did the exact same thing, set the denominator equal to 0, found out what values of x gave us 0 in the denominator. The only difference is we had a trig function there. So I hope you found this video interesting. I was thumbing through a book and saw this problem, figure, hey, let's make a video on it. Something a little bit different. All right, so thanks for watching. Check out my other videos. Give me a like, share, subscribe, comment, and I'll see you in the next one. Later.